Have you seen the graph of the sine function? Let me show it to you. There. Notice this curve. This is known as a sinusoid. Now focus on the portion of the graph between minus 4 pi and minus 2 pi. You see this? Now look at the portion between minus 2 pi and 0. Now shift your attention to 0 and 2 pi. And now observe the portion between 2 pi and 4 pi. Did you notice something? Each part of the graph was exactly the same. What does this mean? We were talking about an interval of 2 pi in every case. This means that the value of sin x repeats after each interval of 2 pi. You don't believe me? Go back to the graph. Look at sin pi by 2. Its value would be 1. Now what is pi by 2 plus 2 pi? Simple calculation. 5 pi by 2. So look at the value of sin 5 pi by 2 now. Its value is also 1. So the value of sin pi by 2 equals the value of sin pi by 2 plus 2 pi, or sin 5 pi by 2. You believe me now? In fact, this is a very important property related with the sine function. And we use this property to find the values of sines of very large angles. So let's take the example of sine of 1830 degrees. Now we can say that 1830 degrees equals 1800 degrees plus 30 degrees. Now what about 1800? We can also say that it equals 5 into 360. So our expression now becomes sine of 5 into 360 degrees plus 30 degrees. And 360 degree is nothing but 2 pi. So we can write this expression as sine of 5 into 2 pi plus 30 degrees. Now let's use the property. The value of sin x repeats after an interval of 2 pi. What does this mean? This means that sine of 5 into 2 pi plus 30 degrees is nothing but sine of 30 degrees. So we have sine of 1830 degrees equals sine 30 degrees. And sine 30, we know its value. That's 1 by 2. So the value of sine of 1830 degrees is 1 by 2. And this is how you use this property.